This is Geometry Unit 1, Lesson 3 on factoring. Factoring, remember from Algebra 1, is the process of figuring out what was multiplied to get your polynomial. So before we start factoring, let's remind ourselves how we multiply in algebra. We have 2x times 3x minus 4, a monomial times a binomial. This is just the very basic way of multiplying. You want to use the distributive law. We multiply the 2x by each of those terms. 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. And there we have it. Now, you can actually apply the distributive law twice and do two binomials, but we usually call that FOIL. X plus 2 times 3x minus 4. X is multiplied by both of these terms. X times 3x is 3x squared. X times negative 4 is negative 4x. 2 times 3x is 6x. And 2 times negative 4 is negative 8. First, outside, inside, last, or FOIL. Combine your blank terms. 3x squared plus 2x minus 8. And there we go. Distributive law, reverse or FOIL, or a double distributive. Now, when we factor, we undo those processes. When you factor, you reverse distribute or you reverse FOIL. But first, always look for a GCF. Your life will be much easier if you take out a GCF because it makes your numbers smaller and usually easier to factor. So we always try to do that first. And then factor the remaining polynomial if possible by either reverse distributive or reverse FOIL or any other method that we come up with. Now let's start with our most basic kind of factoring, which is factoring by reverse distributive, which is factoring by GCF. When you do that, you find a GCF of the entire polynomial. 12x minus 20 has a greatest common factor of each of them of 4. So I can factor 4 out of each one of these. So I put my GCF of 4 out in front, and then I divide each of the terms by the GCF. 12x divided by 4 is 3x. Negative 20 divided by 4 is negative 5. So 4 times 3x minus 5 is 12x minus 20 factored. If I were to re-multiply this by the distributive law, I will get 12x minus 20 back. Now, remember, when you're factoring by reverse distributive and using the GCF, your GCF doesn't have to be just a number. It can also be variables. If we look at 2x cubed minus 6x squared minus 4x, what do all three of these terms have in common? Well, number-wise, they have a 2. 2, 6, and 4 all divide by 2. However, notice there's an x, at least one x in each one of these terms. So my GCF is actually going to be 2x. Now, if I divide each term by 2x, 2x cubed divided by 2x is just x squared. Watch your multiplication rules. Negative 6x squared divided by 2x is negative 3x. And negative 4x divided by 2x is negative 2. So 2x times x squared minus 3x minus 2. If you're not sure if it's right, re-multiply it and make sure your exponents work. So that's reverse distributive. The next one, factoring by difference of squares, is a special pattern of factoring. It's called difference of squares because the first and last terms are perfect squares, and difference means there's a minus in the middle. This factors is a specific pattern. It's a double bubble, 2 sets of parentheses. How do you get a squared? It's a times a. That goes in the first term. And then to get negative b squared, you have to multiply b times b, but how do you get the negative? Well, to get it to be negative, one has to be plus, and one has to be minus. So it's plus b and minus b. Now notice there's no middle term here, and that makes sense when you think about this. If you FOIL this, your outside-inside term is going to be positive ab, negative ab, which adds up to 0. So notice with difference of squares, the factors are identical except for the sign. And it only works because the end terms are perfect squares. So let's try out a couple of these. X squared minus 25. Double bubbles. X and x. Plus and minus. 5 and 5. I knew x squared was a perfect square. I knew 25 was a perfect square. So this pattern works. 4x squared minus 49. 4x squared is a perfect square even though it's got a 4 out front. 4 is still a perfect square. 49 and x squared are all perfect squares. There's a minus in the middle. Make my double bubbles. Now, what gives me 4x squared that's identical? 2x times 2x. I know it's going to be plus or minus. And 49 is 7 times 7. Now, order matters when you're doing this. 9 minus x squared when you factor this. Double bubbles, what gives me 9? 3 times 3. I know it's got to be plus or minus. And then x times x. So 3 plus x, 3 minus x is your factors. Now, can I say x plus 3x minus 3? Actually, no. If I do x plus 3x minus 3, that's telling me my last term is negative 9 and my first term is x squared, and that's not what this says. So order matters when you're doing the factoring, so be very, very careful of that. Watch your signs. Now, how about x squared plus 36? X squared plus 36 has perfect square x squared, perfect square 36. But does it factor by difference of squares? No. Notice this right here. That is a plus. A sum of squares does not factor. At least it doesn't right now. It is a non-real answer. So the sum of squares does not factor because of the plus. It won't work. Now, last one, 3x squared minus 48. Now, obviously, 3 is not a perfect square. Neither is 48. However, don't 3 and 48 have a greatest common factor? They do. It has a greatest common factor of 3. So if I factor out the 3, I'm left with x squared minus 16. X squared minus 16, isn't that the difference of squares? X squared and 16 are both perfect squares. So I can do that, x squared minus 16, as x plus 4, x minus 4. I hope this is coming back to you now. The next way to factor trinomials is using reverse FOIL. Notice here it says a is equal to 1. For this group right here, our first term value is going to be 1. So the value right here is a 1. So all of these are going to start out with x squared. So the first term is going to be x times x. Now, be very, very careful when you're doing these. Watch your signs and watch your rules. Now, for the n term, we need two numbers that multiply to be negative 24. This number right here. But they have to add up to positive 10. Well, if they have to multiply to be negative 24, what kind of signs do you need? Well, to get a negative number, you need one positive number and one negative number. So we know this is going to be plus and minus. Watch your signs. What factors, 1 plus and 1 minus, will add up to 10? Well, it's very tempting to say 6 and 4, but does negative 6 and positive 4 add up to 10? No, it doesn't. But if I look at positive 12 times negative 2, that gives me negative 24. And positive 12 plus negative 2 will give me 10. So for this to work, I need plus 12 and I need minus 2. So when I put this in, 12 would go with the plus, 2 would go with the minus. You can even do your smiley face check to make sure it works. 12x minus 2x is 10x. So x plus 12, x minus 2. Signs are crucial when you do these. Let's try a couple, see if we refresh our memories. Double bubbles, x and x. Now, what kind of signs is this going to have? My last term is positive 24, and it had to add up to negative 10. Well, how do you add up to or multiply to get a positive number? How do you get positive 24? You need to multiply two positive numbers or two negative numbers. Well, to decide, it's got to add up to negative 10, so they would both have to be negative. So this is going to be minus minus. This one is definitely going to be 6 and 4, because negative 6 and negative 4 is negative 10. Now we have x squared minus 5x minus 36. Double bubbles, x and x. This time it's negative 36, so one's plus, one's minus. Now remember, your middle term has to add up to negative 5. So for this to be negative 5, the factors you'd need would have to be negative 9 and positive 4. Negative 9 plus 4 is negative 5, and it works. Now, all of the ones we've done so far have had just a single x squared. Well, how are we going to get this to be a single x squared? You notice anything special about 3x squared, 12x, and 9? Yeah, they all have a GCF of 3, so let's do that first. X squared minus 4x plus 3. Oh, that looks like something we can factor more. So let's try. Double bubbles, x and x. This is plus 3, and it has to add up to negative 4, so it's going to be minus minus, and it's got to be 3 and 1. And that is completely factored by reverse FOIL. So if you can GCF something, take it out. What do we do when we factor larger polynomials? Well, if I have ax squared plus bx plus c as a general form of polynomial, and the a value, the first coefficient, is bigger than 1, and it can't be GCF'd, we might want to use this method. Now, you can use reverse FOIL, but you have to do it by trial and error, and that can be a little picky. Now, here's another method that works every time that you can do. It just takes a little practice to get used to. All right. First thing you do is, what we're going to do is split the middle. Splitting the middle means we're going to turn 5x into the sum of two different numbers based on some information that we know. So the first thing we need to do is find the product AC. All right, A in this case would be 2, C would be 12. So it would be 2 times, technically, negative 12, don't ignore your signs, is negative 24. Now, we take that negative 24, find two numbers that multiply to be negative 24, and add up to be the b value. The b value in this case is 5. So what multiplies to be negative 24 but adds up to be 5? Well, let me see. Negative 24 would be different signs. So if I said positive 8 times negative 3, that gives you negative 24, and positive 8 plus negative 3 will give me 5. Okay, so instead of writing 5x here, I'm going to rewrite this as a split middle term. Instead of writing 5x, I'm going to write plus 8x minus 3x, and then minus 12. Now I'm going to factor this by grouping. Grouping means we take these and split them into two groups. 2x squared plus 8x in one group, plus negative 3x minus 12 in another group, and we have this grouped here. Take each parenthesis and factor out the greatest common factor. 2x squared plus 8x, the GCF, is 2x. And when you divide it out, you're left with x plus 4. Now over here, we have negative 3x minus 12. The greatest common factor of this, I'm actually going to factor out negative 3. And when I divide it, watch your signs. Negative 3x divided by negative 3 is x. Negative 12 divided by negative 3 is 4, x plus 4. Now, you may see something interesting here. What do you notice about this term and this term? What do they have in common? Well, they have x plus 4 in common right here. Here's x plus 4. That whole term is a common factor. We can treat it as a GCF term like we put on the outside of a set of parentheses. So we're going to put x plus 4 on the outside. What's left when we take x plus 4 out? If I take this out, I'm left with 2x. If I take this out, I'm left with minus 3. And look at that. I've got it factored. X plus 4 times 2x minus 3. Okay, let's try one more to make sure we've got this. 3x squared minus 17x plus 20. All right, our first way to do this is we have to find the product of a and c. A and c is 3 times 20, which is going to be 60. Now, I need the factors of 60 that will add up to be negative 17. Well, how do you get a negative number by adding? You have to have two negatives. So 17 is actually going to be negative 12 times negative 5. Negative 12 plus 5 is negative 17. Negative 12 times 5 is 60. All right, so I'm going to rewrite 3x squared minus 12x plus negative 5x plus 20. So instead of writing negative 17, I have negative 12 plus negative 5. Now I'm going to group it. And notice here I have a greatest common factor on each one. The greatest common factor of this group is 3x, which gives you x minus 4. Now, notice here my binomial is going to be x minus 4. I want this to be x minus 4. That might tip me off. I've got to factor out a negative. So if I factor out negative 5, I get x minus 4 as well. Now my GCF is x minus 4 times 3x minus 5. So that is factoring by splitting the middle. Looking at x squared plus 8x minus 20, I can do this by splitting the middle, but why would I? This is really easy to do by reverse FOIL. So x and x, negative 20 means it's going to be plus and minus. Factors of 20 that give you 8 are going to be 10 and 2.